We're on this computer. All right, slideshow. Current slide. All right, so today we're going to go over chapter 12, which is experiments with more than one independent variable. I think that this applies to you, Haley, because you are doing a study on gender and age. So this is going to be your study. Hey, Alicia. So just to go over some deadlines, we do have the revised intro, method, results, and discussion due this Sunday. So hopefully you've been working on that. Alicia, I know you've been working on it. I've been getting some emails and it sounds like you're making a lot of progress. So today we'll discuss the lecture on studies with more than one independent variable. And then on Wednesday, we'll go over IRB information because you do have to submit an IRB on Sunday. That should be pretty easy, and your discussion. Are there any questions from last lecture or anything about your papers that you might want to discuss?
I had a question.
Sure.
So last time we went over like the results section, but since mine's like the two-way ANOVA, I wasn't sure what to do, so I haven't gotten to that part yet, but.
Okay.
Yeah.
Do you have time to meet after class maybe?
Yeah, that should be fine.
Okay, so we'll talk about it after class, and I think I might just keep recording in case someone else is doing a two-way ANOVA, but off of the top of my head, I can't remember. But any other questions or comments? Alicia, do you get your question answered?
Yeah.
Okay. So nothing else? No? Okay. So today we're going to talk about experiments with one independent variable, which is everything we've been talking about so far. We'll talk about why experiments with two independent variables are important. And one of the reasons why they're important is that they can show interactions. They can give us some information about the generalizability of our findings. Then we'll talk about factorial variations. So when we have more than one independent variable in a study, we call it a factorial design, and we'll explain what that means. And then we'll talk about how you can identify factorial designs in some of the articles that you read. Cool. All right, so in this study, so in these graphs that are presented, they're investigating cell phone use and driver reaction times. So the question that these researchers had was, are people angry drunks? So the study was conducted by Aaron Duke and colleagues looking at the effects of alcohol on aggression. So the placebo group, which is this pink group right here, drank orange juice with a very small amount of vodka in it. If you've had vodka, you know it smells a lot. So it only had enough for you to be able to tell that it had vodka. And then the alcohol group, which was the drunk group, they drank enough vodka to reach a 0.10 blood alcohol concentration, which is enough to make you a little drunk. Then participants, after they were drunk or in the placebo group, they played a computer game with an opponent who was in another room. So they were told there's another participant in the other room, when in reality, this other person was just a computer. So when the player made a mistake, the participant was able to deliver a shock as a punishment. So what they measured in this study was the intensity of the shock and the duration of the shock. So again, they were investigating whether being drunk makes people aggressive or angry. And the way that they operationalized getting drunk is the amount of vodka that they had in the orange juice. And the way that they measured aggression was the intensity of the shock that was given to the other participant when they were made a mistake, and the duration of the shock. So what they found in this study, does anyone want to explain the results to me, or do you want me to walk you through? Rick, what does this study show, this graph A?
Well, that the drunk group gave the computer more shocks. It was more aggressive.
Yeah, so the intensity of the shock was greater for the drunk group than for the placebo group. Great. And that confirms their hypotheses, right? So they were a bit more aggressive. Alicia, can you walk me through graph B?
Those in the drunk group were more likely to give the longer shocks than the placebo group.
Perfect. Yeah, exactly. So that confirms their hypotheses. So here they had one independent variable, whether they were in the placebo group or drunk group. So the alcohol intake and the dependent variable, they had multiple dependent variables, so duration of shock and intensity of shock. So that's interesting. That gives us some information, but it only gives us information about what happens in the lab. A second study that we'll be talking about, I'm just going to walk you through it right now, just so that you keep it in mind while we're talking about other graphs. So this study looks at cell phone use while driving. This was done in the early 2000s before there were any laws about cell phone use while you're driving. And this is one of the studies that was used to pass laws against cell phone use while driving. So in this study, Strayer and Drews instructed participants to talk on a hands-free cell phone while playing on a realistic driver simulator. So they were sitting in front of a machine that actually simulated their driving. So for 2 segments, they carried on a conversation on the phone. And for the other 2 segments, they weren't on the phone. So the order was counterbalanced for participants. What does counterbalance mean again?
They changed up the order of treatment.
Yeah, so what was the treatment?
The alcohol intake.
Oh, this is the second study. So this
Oh.
is on cell phone usage. So they either talked on the cell phone or didn't talk on the cell phone for the duration that they were driving. So some people started talking on the cell phone and then they didn't talk on the cell phone for the second segment. Some people started not talking on the cell phone and then they started talking on the cell phone for the second segment. So just, yeah, so you're right. So you switch up the order of the treatment. So this is a within subjects design. Okay, so the DV, the dependent variable, was the amount of time it took people to react in milliseconds. And what they found was that drivers using the hands-free cell phone were slower to hit the brakes than those who were not talking on the phone. So in this study, this is what we call a between subjects design. Do y'all remember the difference between a between and a within subjects design?
Is it? Go ahead.
A between groups design has 2 groups of subjects and they each see a different level of the independent variable, and a within groups design is just one group that sees all levels.
Perfect. Yeah, so the second study I talked about the cell phone, they either talked on the phone or they didn't for 2 different segments of driving. And in this study, between subjects design, they were either in the placebo or the drunk group. They were looking at the intensity of the shock and the duration of shock. It would be hard to run a study like in an hour where you're like, okay, so you guys are going to be drunk first. Let's see how strong you give the shocks to people. And then half an hour later, they might still be drunk and then you give them the placebo and then you have to do it again. So it'd be hard to do a between subject study there, right? And we talked about some strengths and weaknesses, but that's exactly right. So this is just a review of studies with one independent variable. So why is it important that we talk about studies with 2 dependent variables? So this is sort of why Haley decided to do both gender and age. So why did you decide to do gender and age and not just gender or age?
Well, I felt that there was like studies done on like race and gender and like other things, but I wanted to do like age and gender, I guess, because there wasn't really anything done on that.
Yeah, but why not just age?
Just to have like a comparison, I guess.
Yeah, so maybe it's because people treat others differently, like women who are older are treated differently than men who are older, and women who are younger are treated differently than men who are younger. So you want to see the interaction between age and gender.
Yeah.
So what an interaction is, that's what we talk about when we talk about studies with more than one independent variables. This occurs when one level of the independent variable affects another level of the second independent variable. So when we're doing an interaction effect or investigating an interaction effect, It allows us to determine whether it depends, whether the changes in aggressiveness depends on something. So let's consider the cell phone and driving study. So you could do the cell phone and driving study, and you might say, well, maybe the reaction times depend on age. So maybe younger people, their reaction times might be faster because they've spent more time using cell phones, right? So they might be used to it. Whereas older people, one, because they're older, their reaction times are slower, and two, because they don't have as much comfort using a cell phone, they might just have longer reaction times. So in that way, you would want to investigate whether the reaction times when using a cell phone differ by age. So that would be an interaction effect. So another way to describe an independent variable, or like the interaction effect, is a difference in differences. So it's the effect of one IV, such as cell phone condition versus no cell phone condition, on reaction times for younger versus older drivers. So it's the difference in reaction times between older and younger drivers. Or for Haley's study, it might be the difference in job experiences or sexual harassment.
Yeah, job satisfaction and sexual harassment.
Yeah, so differences in job satisfaction between women and men depending on age, or between young and older people depending on gender. So we'll talk about how you can determine an interaction on the next few slides. Designs with two independent variables, things get really complicated because you can have factorial designs with more than two independent variables. I've run studies with like 3 or 4. We'll talk about why that might not be great. We'll talk about how it can test limits. So this is about the generalizability, right? So you might do this study on cell phones, but you didn't take into account age. So the people that are might be thinking about writing up some laws to pass might say, well, we want to see if this applies to all drivers or if it's just younger or older drivers. We'll talk about how designs can test theories and how to interpret the results. All right, so when you look at interactions, you can have, these are just some combinations of interactions that you can have. So one is a beautiful crossover interaction. So if I were to present you with a graph and it looked like this with an X, and I asked you if this was an interaction, you would say yes. So anything that looks like an X has an interaction. So in this study, they're investigating whether your liking of food depends on whether it's cold or hot. And the answer is, it depends, right? So some foods you like cold, some foods you like hot. So you might like ice cream a lot when it's cold and hate it when it's hot. Whereas for pancakes, you might love pancakes when they're hot and hate them when they're cold. So this is saying the liking of food depends on whether it's hot or cold. So how much you like it depends on whether it's hot or cold. So soup, unless it's gazpacho, you probably want it hot. My boyfriend is weird. He will eat anything and enjoy it, whether it's hot or cold, which is not great. But for most people, this is the interaction. So this is called it depends, and it depends interaction. So whether you like cold or hot food depends on the kind of food. So this is known as a spreading interaction. So here it's graphed one way and here it's graphed the other way. The author of the book talked about her dog. So she's looking at the proportion of time the dog sits. So if you don't say anything, the dog is probably not going to want to sit, right? Because you're not telling it what to do. It can't read your mind. But when you say sit, the dog is more likely, has a higher proportion of sitting when you're holding a treat versus when you're not holding a treat. So here it's telling you that the dog will only sit when you're holding a treat versus when you're not holding a treat. So this interaction is known as an only when interaction. So this is another way to graph the same finding here. But what you can do is change the categories such that the lines here holding a treat or no treat are now the on the x-axis. So holding a treat versus not holding the treat, And what was on the x-axis, say nothing versus say sit, are now representing the lines. So as you can see, the pattern is reversed. So when you're holding a treat, the dog is more likely to sit when you say sit versus when you say nothing. When you're not holding a treat, it doesn't matter whether you say nothing or say sit, the dog will not sit. Does that make sense? So essentially what this is saying is the dog will only sit when you say sit and you're holding a treat. So sometimes, so here there are 4 different cells, and we'll go over the cells on the next slide. And what it's telling us is that there's only a difference in one of the 4 cells. So the other 3 cells serve as a comparison. And you might say, well, you're wasting all these treats, or you're wasting your voice by saying sit or not sit. But that's part of the research process. So this is kind of like the golden goose when we're looking for crossover interactions. This is beautiful because it tells us it depends on multiple things. And sometimes it does exist, sometimes it doesn't. But this is just telling us X only exists when Y is true. So here is what I mean when I'm talking about a factorial design and when I'm talking about cells. So again, this is the study where people were on the cell phone versus not on the cell phone. And let's say that they decided to also add younger drivers and older drivers, like I proposed. So a factorial design is when there are more than 2 independent variables. So each of the factors is called each of the independent variables is called a factor. So factor number 1 would be cell phone, presence or absence. Factor number 2 would be the age of the driver, younger or older. And now because you have 2 factors, you multiply them so that you can get how many cells you will need. So for instance, here, you will need younger drivers that are on cell phones, younger drivers who are not on cell phones, older drivers on cell phones, and older drivers not on cell phones. So for Haley's study, she's doing people that identify as women, people that identify as men, younger people, older people. So she'll need to have women that are younger, women that are older, men that are younger, and men that are older. So why do we care about the conditions? So knowing the cells in your study let you estimate how many participants you might need in your study. And this is something we talked about last week, where we talked about the standard used to be that you need about 50 participants per cell. So that would mean for Haley's study, she would need about 200 people, 100 men, 100 women, but more specifically, 50 young women, 50 older women, 50 young men, and 50 older men. Okay, does that make sense? Yeah, okay. So you can use factorial designs to study manipulated variables or participant variables. So Haley can't manipulate gender or age, so she's investigating participant variables. Here, they're using both participant variables and manipulated variables. The manipulated variable here is whether they're on a cell phone or not. The participant variable is whether the drivers are older or younger. So they couldn't manipulate age because they can't assign people to be young or old. Thus, age is a participant variable, and it's treated as an IV in a factorial design. Although, has anyone taken any gerontology classes with Dr. Cannon? Well, she has this thing. She bought these goggles that mimic some of the issues that older people experience with their vision. So if you had those things, those goggles, you could potentially mimic older age. So one of the things she has students do, I think, as part of their final paper, is she has them go out on campus and wear these goggles and see what it's like to be an older person on campus that might have vision problems, which I think is really cool. So in that way, you could manipulate older age. Okay. Also shout out to the gerontology department. They're really cool. I wish I could take some of their classes. All right, so why else are factorial designs interesting or important? so they can test limits. So we found, or we talked about the finding earlier, that people who are on the phone have slower reaction times versus those that aren't on the phone. But here we're testing the limits. Does this effect only occur for younger drivers? Does it only occur for older drivers? Or does it happen for both groups equally? So what does this graph tell us? Does anyone want to take a stab at it? Does this look like an interaction?
No.
No, it's a comparison.
No, it doesn't look like an interaction. Great. So another point that I forgot to make is usually interactions, if you extend the line. So if you were to extend this line and you were to extend the orange line, it looks like it would be an X, right?
Yeah.
So when you look at interactions, even if the lines don't necessarily cross, if you were to imagine both of them going on ad infinitum, so forever, would they ever cross? And if they ever cross, then yes, there's an interaction. So here, even if you were to continue making them go on forever, it looks like they would never cross. Thus, there's no interaction. So because there's no interaction, what does this tell us about younger drivers and older drivers being on a cell phone or not on a phone on their braking time? So in this study, they wanted to see whether there was an interaction of being on a phone or not on a phone by age. And we're saying, or you all told me, there is no interaction here. So what does that mean in terms of the findings for the study?
The age does not impact, or it does not have an impact on whether you're on a cell phone or not.
Perfect. Yes. That's exactly the finding. So age doesn't have an effect on braking time onset, whether you're using a cell phone or not. So in other words, there was no interaction between cell phone and age. So cell phone, the effects of talking on a cell phone don't depend on age. So you can see that older drivers overall tended to be a little bit slower than younger drivers, but that didn't depend on cell phone usage.
Oh, okay.
So there was a main effect. We'll talk about that. So there was no interaction. Perfect. There was a main effect of age, saying that older drivers tend to have slower reaction times than younger drivers overall. But, and there was also a main effect of cell phone usage, such that not being on a phone, you had faster reaction times relative to not being on a cell phone, but there was no interaction. And we'll talk about what that means. So does the fact that there's no interaction make sense here? And then the interpretation. So if you were taking the final, for instance, and you saw this graph and you saw these numbers, there are multiple ways that you can talk about an interaction, one of which we just said is viewing that the lines never cross. And we'll talk about interactions shortly that you can calculate using these numbers. But if you're on a time crunch, you can just look at the graph and say they'll never cross, so there's no interaction. Thus, as Alacia said, age does not affect whether the cell phone condition contributes to braking onset time. Okay. All right, so factorial designs can test limits. So here it's telling us, like Alacia said, that being on a cell phone or not being on a cell phone has more of an effect on braking onset time, and it's not limited by the age of the participant. It happens irrespective of the participant's age. So if you're trying to pass a law, that would be great news. All people should not be on cell phones, or no one should be on a cell phone while they're driving. All right, so here's another way that they can test limits. So one is a form of external validity. In the last slide, did the cell phone study have good external validity or bad external validity?
Good.
So what's external validity again?
generalizability of a study.
Yeah. So we're trying to look at the generalizability of cell phone versus no cell phone usage. And was there an interaction with age? No. So was the study generalizable or not to people of different ages? Haley?
I want to say yes.
Yes.
Because,
So it had,
yeah,
yes. Uh-huh.
because it still has like, well, if like this study shows there's no effect and it has good external validity, then that means it can still be generalized to the other population. It doesn't mean that just because there's no interaction that, oh, okay, so since there's no interaction for these, like in this experiment, it would generalize to the fact that there's no interaction for other age groups, right?
Yes. So who could we generalize to based on that study? On this study? Could we generalize to Latino and Asian and white people and people living in other countries?
Hopefully, if their sample was
No.
representative.
No. So based
Only-
on this data, it doesn't tell us anything about the representation of
Yeah.
race. But Rick, what were you going to say?
Only older and younger people.
Yes. So what you could say, you're limited in saying just by the limited information we have on this graph, is that we can generalize to drivers of all ages. So it has high external validity when it comes to age of the driver. If we wanted to see race, then we would have all the different races on cell phone and not on cell phone. We found no interaction between race and being on a cell phone or not being on a cell phone on breaking time onset. Then we can also generalize to race. Does that make sense?
Yeah.
Okay. I'm trying to put all the things together. So I'm like, what's external validity? And what is this? And what is that? But hopefully it makes more sense as we keep going. But interactions basically tell us the limits of our findings. And the limits here are either being on a cell phone or not being on a cell phone with younger and older drivers. So let's talk about this study. So what is one thing that might affect how drunk you get?
Wait.
Wait. So in this study, they're extending the study on the drunk group and the placebo group. Remember, the people who get a little bit of vodka in their orange juice or enough vodka to get someone drunk. And they tested this among lighter men, 151 pounds, and heavy men, 215 pounds. And the argument is the amount that it takes someone to get drunk might differ based on weight. So it might take a lot more alcohol to get heavy men drunk versus light men. So let's see. Does this look like, so this is the shock intensity scale dependent variable. And this is the same graph, but just with the independent variables and the lines switched up. So let's just focus on this one. This one. Does there look like there's an interaction?
Mm-hmm.
Yes. Okay, so can anyone tell me what the interaction looks like? Or just general, there's an interaction between what and what?
Between weight.
Okay.
Between weight and how intense the shock they give us.
Close. So there's an interaction between weight and whether they're in the drunk or placebo group on shock intensity. So when you talk about the interactions, it's always the independent variables on the dependent variable. So does anyone want to walk me through the graph? If not, I can walk you through this one and then I'll ask you to walk me through one in the future. I'll walk you through this one because talking about interactions are really tough. And I remember when I was prepping for my job talk, I had to I had to practice this a lot because they're tough. So in an interaction or a 2x2 interaction, there are 4 different comparisons that you can make. So I am going to start with light men, I'm going to go on to heavy men, and then I'm going to make the comparison between drunk group and placebo group. So among light men, those who were drunk gave slightly higher levels of shock intensity than those who were in the placebo group. Among heavy men, this effect seems to be strengthened. The heavy men who were in the drunk group gave a lot more, significantly more shock intensity than those who were in the placebo group. So we see here is that the weight of the participant magnified the shock intensity, depending on whether they were in the drunk group or not the drunk group. So here I talked about these endpoints here, and now I talked about these endpoints here. So that's the first pair of comparisons. The second pair of comparisons are going to be within each line. So among those in the drunk group, the orange line, as weight increased, the shock intensity also increased. But among those in the placebo group, the green line, weight had a very, very marginal difference or very marginal effect on shock intensity. So the first comparison you make is here. Second comparison you make is here, or it depends on the x-axis. And then the second pair of comparisons you make based on the lines that are on the graph. So you're going to make 4 comparisons total. So this wasn't necessarily in line with their hypotheses because the heavy men that were in the drunk group seem to have given the biggest shock intensity. So this might tell us, one, maybe the heavy men varied in the extent to which they were lightweights or heavyweights when it came to drinking. Or it might be that the alcohol isn't necessarily driving the effect. Maybe the heavier men just have more aggressiveness hormones in their blood, right? So this is telling us is that this study doesn't necessarily extend to people of all weights. It might be magnified for people that are of heavier weight than lightweight. Rick, you look very confused.
Oh, well, there are other factors.
Yeah. Does that make sense, Alicia?
Yeah.
Okay, who wants to walk me through this one? Okay, Rick, can you go through these lines? So among those in the placebo group, what did they find?
Oh, well, well, the placebo group responded less than the drunk group to the shock intensity. Or
That is only,
sorry.
that's only one independent variable. So I want you to compare in the placebo group, just this point on the orange line and this point on the green line. So in the placebo group, what is the orange line?
The orange line is, I thought that, oh, I see. Light men and heavy men, sorry.
Okay, so among those in the placebo group, was there a difference in shock intensity between light and heavy men?
Very little.
Yeah, so I would say there was no difference.
No
So one way
difference.
to say that is among those in the placebo group, weight had no effect on shock intensity.
Okay.
Alicia, do the drunk group for me, for these 2
Um,
points.
in the drunk group, the light versus light and heavy had no impact on, or
Does this look like a difference though? A score of 5 to 7?
oh, then okay, then yeah. So
Okay.
wait. So if there is a difference, it'll show a larger gap then? Oh, okay. I was thinking the other way around.
Okay, can you tell me again? So among those in the drunk group, who scored higher on shock intensity?
Heavy men.
Heavy men
first.
had higher levels of shock intensity relative to light men. Does that make sense?
Mhm.
Okay, I'm going to ask you guys to do this again for future slides. So Haley, do you want to do the orange line or the green line?
Sure. So within the light men group, the difference between the alcohol intake and the shock intensity varied a little bit. 'Cause
In
it's
what
not-
way? Yeah.
The drunk group had within the drunk group, the light men, their shock intensity was a little higher than within the placebo group.
That is very, 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 very close. This is really hard. So what you would say is among light men, people in the drunk group had slightly elevated levels of shock intensity relative to people in the placebo group.
Okay.
And notice how I say like among light men. And when you do this comparison, you're like among those in the placebo group, and you talk about the differences here. Among here is among the drunk group. There were differences in light and heavy men. But now when you're doing the lines, you say that it's among light men and the difference is between placebo and drunk. And who wants to take a stab at the green line?
Can I try again?
Sure.
Okay. So among heavy men, the drunk group had a higher shock intensity levels than within the placebo group.
Perfect. So this is really tough. So if it's taking a little bit of time, I completely understand. It's pretty hard, especially when we're learning like how to, is this the first time you guys have talked about like graphs and how to interpret them?
Yeah.
These
Yeah.
graphs, yeah.
Yeah, okay. So it completely makes sense if it's tough, but we'll keep practicing. So like I said, I had to practice it a lot for my job talk, and that was like 3 years ago. So you guys are doing just fine. So vectorial designs that can test theories. So you might have a theory about how a variable might interact with another. So a factorial design is a good way to test an interaction to see if the results are consistent with your theory. So on the next slide, I'm going to talk about a study that uses an interaction to test a theory about memory. Okay, so let's say that in the prior studies, which we've already talked about, we found that alcohol did have an impact on aggression, which we did. And we might be wondering why. So there might be multiple theories about why alcohol might lead to aggression. One theory that researchers had was that alcohol can become cognitively associated with thoughts of aggression. So it's not necessarily that alcohol increases the output of hormones or neurotransmitters that affect aggression, but it's the fact that we've been exposed to so much media that shows when you drink, your inhibitions are lowered and you're more likely to get in a fight or be aggressive. And that's what we see in the media, right? When people get drunk, they fight in bars and they do all this other stuff. So what they're saying is it's not necessarily the fact that it increases your neurotransmitters for aggression, but that it's associated with aggression-related words in our minds. So Bartholow and Hines in 2006 tested this theory by having participants view images and words on a computer monitor. So this is something that's called priming. And what we do is we might present you with either photos of alcohol or photos of plants. And then we present you with these words, so either aggression-related words or neutral words. And they're presented very quickly. So sometimes the photo related to alcohol and other times the photo was of a plant. So it's hypothesized that participants would respond more quickly to identify aggression-related words relative to neutral words. And then here are the cells. So again, participants were either exposed first to an alcohol photo or a plant photo, and immediately following that, there would be a flash of a word, and you would have to say whether it was an aggression-related word or a neutral word. The reaction time it took you to respond to that word was a dependent variable. And what they argued is that the alcohol photo activates the cognitive schema of aggression. So after you see the alcohol photo, you're going to be quicker at identifying aggression-related words relative to when you see the plant photo, which shouldn't have a difference in how quickly you respond to either aggression or neutral words. Does that make sense? Yeah, so Rick, Alacia,
I think so.
Haley.
Yes.
Okay, so let's see what they found. So here we have 4 different cells. So people viewed the alcohol photo. They're looking at how quick they responded to the words, either aggressive or neutral. And they have the plant photo, whether they think that, or how quickly they responded to words that were aggressive versus neutral. So what is their hypothesis here? Among those in the alcohol photo condition,
The aggressive word type and the alcohol photo type would react quicker.
quicker than all of the rest of the conditions.
Yes.
But among those in the alcohol photo, you would make a difference here. So aggressive words would be reacted to more quickly than neutral words. And among those in the plant photo condition, they predicted no difference. So there would be no difference in reaction time between aggressive and neutral words. And then we can also make this comparison. So these are all the comparisons that we make on the graph. Among those who viewed aggressive words, people in the alcohol photo condition responded faster than those in the plant photo condition. Among those in the neutral condition, people in the alcohol photo and plant photo condition did not differ in their reaction time. So let's see if that's what they found. So that's part of their hypotheses. So let's see what they found. All right, so first, is this an interaction?
Mhm.
Yes.
Perfect, we got that down. All right, so who wants to walk me through this comparison among those in the alcohol photo? Alacia, walk me through it.
So, the alcohol and
It's okay,
Yeah.
so I'll get you started. So among those in the alcohol photo condition,
one's in the alcohol condition, there was an impact on reaction time in, wait, no. Wait. I'm like forgetting how to word it.
it's okay. Does anyone want to step in and help?
I can try.
Okay,
So among those in the alcohol photo group, there was a faster reaction time in the aggression-related word group compared to the neutral word group.
yes. So this reaction time, I fucking hate it. I'm sorry, because slower or lower numbers means faster. So that sucks because you want to say like, oh, they were more in the neutral versus aggression, but Haley's absolutely correct. The aggression related words were faster than the neutral words. Perfect. So Alacia, what you do is alcohol photo, there was or was not a difference, and then you say what the difference was between these two conditions.
Okay.
Do you want to try the plant photo?
Sure.
Okay.
So in the plant photo condition, there was a difference in reaction time between aggression and neutral related words.
And in what way? Who was faster?
The neutral words reacted quicker than the aggression words.
Yes. Great. Rick, do you want to try, which one do you want to try? The dark blue line or the light blue line?
I don't know. The light blue is aggressive related words.
This light blue is neutral.
The neutral.
Mhm.
So we're doing something to, let's see. So for the, I don't know how to begin to word that. For the neutral words, for those that were giving, I don't know, let's see, I got lost.
So those who viewed the plant photo, what? Among those who saw the neutral words,
Reaction time was less than
was
those
faster
was faster than the
in the plant photo condition.
in the plant photo, faster in the plant photo condition than those in the alcohol photo condition.
Perfect. Yeah,
Okay.
this is really hard. Okay, who wants to do the dark line?
I will if nobody else wants to.
Okay, go for it.
Okay, so among those in the aggression-related word group, the reaction time was quicker when they viewed an alcohol photo when compared to a slower reaction time when viewing the plant photo.
Perfect. Yep. What would be more helpful? Would it be more helpful for me to walk through these more rather than asking you, or does it help for me to ask you?
I think it helps to ask. It just takes me a while to like get it all, because like I understand like the interactions. It's just the wording is what's getting me
Yeah,
mixed up.
it really sucks. I understand. I completely understand. It took me some time to get it too when I was an undergrad. So so this is
Also,
Mhm.
excuse me.
Go ahead.
Also on this one, the reaction time, which is faster, it's almost reversed a little bit in the thought.
Yeah, so this is a cluster F. So
Yeah,
but why do they do that? That's just how we talk about reaction time.
Well, that's weird. Like
It
the
is.
orientation of the graph.
It is really weird because it's counterintuitive. I agree. But these are the numbers that you would use if you didn't have a graph. And this is what we use statistically to tell us whether there is an interaction. So this theory supports, so these findings support the theory that people cognitively associate alcohol cues with aggressive concepts. Does that make sense?
Yes.
Alicia and Rick? Yeah?
That makes sense.
Okay. All right. So this is another study. This is about memory. So in this study, researchers used a factorial design to test their theory about why memory develops with age. So the results showed an interaction that was predicted by the theory. Children's memory capacity can be better than adults when they know a lot about the topic. So in this study, they recruited child experts of chess versus adult novices, so adults who had no experience like me with chess. And they had an independent variable. They had them memorize either digits, so like 1, 4, 8, 12, et cetera, or they had them memorize chess pieces. So again, the child experts might be really good at remembering the chess pieces because they know a lot about chess versus the digits. The number of items recalled was a dependent variable. So how many digits versus how many chess pieces you remembered. And the results shown here tell us what? Is there an interaction?
Yes.
Okay, what is the interaction between?
Child experts and adult novices and oh my gosh.
It's okay. So yeah, participant type by
Type of item.
type of item. Perfect. On the number of items recalled. So here they wanted, should I talk about the design again? Was that confusing?
Sure, one more time.
Okay. So they were looking to see whether so the theory is that generally older people might have a better memory, right? But they wanted to test whether that might be affected by the kind of things that people have to remember. So one aspect in which children might have a better memory is with something that they're experts on. So some people might study like cartoons, like Dora the Explorer. Can they name all the characters versus an adult? Because that's something that they might really care about. But in this study, they use child chess experts. So these children are exposed to chess items all the time. They might know all of the different pieces versus adult novices. Like me, I don't play chess. I haven't tried to play chess in the last 10 years. I don't know any of the pieces. So they wanted to see whether memory or the number of items recalled would be different between both the age of the people, whether they were experts in chess or not, and the items. So if memory is just better among adults, it doesn't matter whether you have chess pieces or digits, you'll be good at remembering both. And if memory among children sucks, then it won't matter whether you give them something that they're experts in, like chess pieces or digits, they'll just be bad. But their theory is that children who are experts in chess will probably remember more chess pieces because they are experts in chess relative to digits, whereas the opposite might be true for adults. Does that make sense?
Yes.
Okay, so now there is an interaction. So can someone tell me what happened with child chess experts? So here we have the number of items recalled, and they were either given chess pieces or digits. So among child chess experts, was there a difference in number of items recalled?
Yes.
What kind of items did they recall more?
The chess pieces.
So among child chess experts, their hypotheses were confirmed. They remembered more chess pieces relative to digits. So their hypothesis was correct. Children who have an expertise in something are more likely to remember things that they have an expertise in relative to numbers that might not mean anything to them. Does that make sense?
Mm-hmm.
Okay, what about adult novices?
Among the adult novices group, the number of items recalled in the for digits was higher than chess pieces.
Yeah. So for older adults, we might need to remember more numbers when it comes to phone numbers and things like that, even though Rick and I probably had to remember phone numbers. I don't know if the rest of you had to remember phone numbers because you can just dial it on your phone. So adult novices, they weren't experts on chess pieces, so they probably had more practice with digits, so they recalled more digits than chess pieces. Does that make sense? So these two comparison points tell us that yes, children have a better memory when it comes to things that they're experts in relative to adults. All right, so now let's do the light blue line. Haley, are you outside?
My window's open.
Okay, no, it's
Yeah.
cool. I can hear the birds chirping.
Sorry, I can mute myself.
No, 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 no. That's
Okay.
cool. It's pretty cool. Okay, so who wants to go through the digits? This line.
I can. People don't want
Let me give Alicia a shot.
Um, okay. So I know I'm gonna mess up the wording, but
No, 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 it's okay. Okay, let me get you started. So among those that were asked to recall digits,
among those who were asked to recall digits, the uh, child expert group was able to, or no, wait, recalled less than those in the adult novices group.
perfect. Yes. So among those who were asked to recall digits, the child chess experts recalled less digits relative to the adult novices. Perfect. Rick, do you want to try the dark line?
Okay. Among those who were recalling chess pieces, the child chess experts recall more than the adult novices.
Perfect. You guys got it. Yeah, that's it. All right. So this finding provided support for their theory that children also have good memory, particularly when it comes to items that are important or relevant to them. Cool. Oof,
Makes
great.
sense.
You guys are getting it. That's great. It's so hard, but I think it helps to talk about it or talk through it. All right, so now we're going to talk about what main effects are, what interactions are. So for main effect, we just want to see, is there an overall difference? For interactions, we've sort of been talking about them and interpreting them. So is there a difference in differences? And something important to note is that when we're running a study that has multiple independent variables, our interest lies more with the interactions than the main effects. We don't care if we get main effects, but we really care if we get interactions. Then we'll talk about all the different kinds of main effects and interactions that are available in a 2x2 factorial. So just based on what we've been talking about, how many interactions can there be in a 2x2 factorial? Like here.
Looks like one.
How many?
Only see one on that graph.
Okay.
But
Anyone else want to?
4, right?
4. There are 4 interactions because there's an interaction among child chess experts with chess pieces and digits. There's an interaction among adult novices with chess pieces and digits. There's an interaction among chess pieces between child chess experts and adult novices. And there is an interaction among those in the digits condition between child chess experts and adult novices. So there are 4 different interactions that you can test. Yeah, there's one overall interaction, but the differences are there are 4 different comparisons that we make. Yeah, that was just a question. You didn't have to get it right. I just wanted to see like if talking about it might help, but I think it helps. All right, here we go. Here are the numbers. Everyone hates this, but it's okay. Let's talk about it. So this is the main effect. So this is the overall effect of one independent variable on the dependent variable, averaging over other levels of the independent variable. So if you have 2 different independent variables, you're going to be looking at 2 main effects. All right, and this study is a word association study. So one independent variable is the type of word, right? So aggressive or neutral. The other independent variable is the type of photo, alcohol or plant. And this is the study that we talked about. All right, so to look for a main effect of word type, you would compute the reaction time to aggressive words and reaction time to neutral words by averaging across the 2 photo condition. So here you're looking for the main effect of word type. So irrespective of whether they were in the alcohol or plant condition, the reaction time for aggressive words was 555. So you take 551 plus 559 and divide by 2. So that's 555. And then among those who viewed neutral words, the average reaction time was 557. So you collapse across alcohol, 562 plus 552 to get the average score, or this is the main effect of word type. So does there seem to be a significant difference between 555 and 557?
No.
No, right? So this would tell us that there is no main effect for word type because the differences here aren't significant. But does it make sense that we're looking at word type across alcohol and plant, so it doesn't matter what the alcohol or plant photo is?
Kind of.
Okay, so essentially what we're saying is, I just care about the word type. I don't care about the photo type. So I just want to know on average, how quickly did people respond to the alcohol, sorry, to the aggressive words, irrespective of alcohol or plant. And then on average, how fast did people respond to the neutral words, irrespective. I don't care if they were in the alcohol or plant condition. So that's why we average across those two.
Okay.
And now the second main effect that we're going to be looking at is the main effect of phototype. So now we're saying among those in the alcohol condition, I don't care if they saw aggressive or neutral words, just overall, those in the alcohol condition, how fast did they respond to the words? So here we have 551 plus 562. So we have an average of 556.5. Among those in the plant condition, irrespective of whether they saw aggressive or neutral words, how fast did they respond to words? We have a 555.5, which is the average of 559 and 552. So here we have this difference. So does 556.5 differ significantly from 555.5?
No.
No. So what we would say here is that there is no main effect of phototype and no main effect of aggressive or neutral words on reaction time. But that's fine. We don't care about the main effects. We did find an interaction though. Whew. All right, so let's talk about this one. This is the second study. So this is the one about body weight and drinking condition, if y'all remember. So can anyone walk me through whether there's a main effect for drinking condition on shock intensity?
So within the drinking condition, in the placebo group, the average was 4.91.
The average for
between
shock? Mhm.
Yeah. And then in the drunk group, the average was 6.60.
Perfect. So does this seem like it could be a significant difference? Yeah, I would say it could be a significant difference. So this would tell us that there's a main effect of what?
Of the drinking condition.
Perfect, yeah. So there might be a main effect of the drinking condition such that those in the placebo group gave less intense shocks than those in the drunk group. All right, Rick or Alacia, do you want to walk me through the main effect of body weight?
I'll try.
That's good, yeah. All I ask is that you all try.
For those in the, as far as body weight, for those in the light men condition or have an average of 5.9, 5.5.
Mm-hmm.
And then in the heavy men have an average of 5.6.
5.96.
5.96. And there's less significant of a difference in that.
So yeah, so I would say there's probably no difference. So there's no main effect of what?
No main effect between heavy man and light man of the shock.
Yeah, so I would say there's no main effect for body weight on shock intensity.
For the body weight on shock intensity.
Yep, perfect. But we found that there was an interaction earlier, right?
Yes.
Okay, so this is just showing us whether there are main effects or not, and I will show you on the next slide similar graphs. But again, main effects aren't as important to us as interactions. All right, so how do you estimate interactions from this? So this might be something that you receive on the final, and you're going to have to calculate the differences on your own. But this is the interaction. The interaction effect is a little bit more complicated. So the table on the top shows how to compute an interaction for the alcohol and aggression study. Okay, so the difference here in the alcohol versus the aggressive and neutral condition is -11. And the plant in the aggressive versus neutral condition is 7. So the differences are statistically significant. So -11 is less than 7. So there's an interaction. So here, instead of doing the main effects, what you're doing is the interaction effect. And the difference is that now you're taking a difference between the aggressive and the neutral in the alcohol condition and comparing that difference to, among those in the plant condition, the difference between aggressive and neutral. Does that make sense?
Yeah.
Haley, does it make sense?
Yeah, I think so.
Okay, so before you were just taking the averages. Let me go here. So you just take the averages, but when you're looking at interactions, you compare the differences between conditions.
Okay.
So here it would be the same thing. The difference between younger drivers and older drivers, the difference is 132, and the difference between older drivers on the cell phone and not on the cell phone is 174. The differences were not statistically significantly different, so there was no interaction here. So how many interactions do we have in this table again?
4.
4. So this is 2 of the effects. So we would have 1 more that we could do after this. Okay. Let me see if there's anything else I forgot to say. Nope, we did all of that. Okay. It's a lot easier, as you can see, to detect interactions or main effects from graphs. For instance, here, is there an interaction?
Yes.
Yeah.
Yes. Here, is there an interaction?
No.
No, not really an interaction. So if the results are plotted in a line graph, you look to see if the lines are parallel. If the lines aren't parallel, then that means that there's an interaction. In the top right, the lines are pretty close to parallel, so there probably is no interaction. But you would need to perform a significance test to find out for sure. Like, I don't just graph my data and I'm like, oh, there's an interaction. We actually have to run statistical analyses, but this is like the first step. Yes, Alicia.
So when you're just looking at graphs like this, like for graph B, like if just like visually the ends don't seem to be that much different from each other, you would typically say that it's not an interaction, even if it might look like there might be an interaction at some point.
Well, I think what you would look at here is the level of parallel lines you have. These look to be pretty parallel. Like, I understand what you're saying, because if you were to go on for infinity, it looks like they would cross eventually. So what I would say by looking at this is that there's probably not an interaction, but there is a possibility. So what I would do is run the statistical test for it to tell me whether there is an interaction or not. But this one very clearly is an interaction. But there are some cases, this is a great point. There are some cases where it looks like there might be an interaction. It's kind of a toss-up. So you might have to verify your supposition based on just the visual cues by running the statistical analysis. So for instance, on the final, if you were to say, well, there might be an interaction because it looks like the lines might cross, I'd be like, okay, well, that's fair. It could be, but if you, and you need to support that with that statement. If you were to say, no, there's no interaction because the lines are pretty close to parallel, then that would also get a point. Because this one's more ambiguous. But if you put, no, there's no interaction here, I'd be like, were you paying attention? Because this clearly is an interaction. So let's see here. What you do with these kinds of graphs is you pretend that there's a point here and a point here, and then you pretend there's a point here and a point here. So that is this data presented in this way. So it would look exactly the same as it does here. If there were imaginary points here, imaginary points here, imaginary points there, imaginary points there. Does that make sense? And then this B graph is the same as this. It's just in a bar graph form. So the orange dots would be here and the pink dots would be here. So the lines would look exactly the same as they would here. So there's just different ways to graph. Let me see, I think I can draw. Pen. So this is what I'm saying. That, and then that. So those lines are interacting or crossing kind of like that. And then I would do that one, and then that one, and they look parallel like that. I think that makes more sense than just like imaginary lines. But okay, cool. Oof, we've been doing this whole time, describing interactions in words. And this is what you already did. Child chess experts can remember more chess pieces than digits, but adult chess novices can remember more digits than chess pieces. So this is putting both of the comparisons together. How do I get rid of this? Oh, I think I like the laser pointer. Okay, for this one, same. So you'd say the drunk group was more aggressive than the placebo group, especially for heavy men. So it's giving you the main effect, drunk group, more aggressive than placebo group. And this is especially true for heavy men. So let's see. Great. Okay. Interactions are more important than main effects. So this is what I've been saying, but why? So when a study shows both main effect and an interaction, the interaction is always more important because there may be real differences in marginal means, but the more exciting part is the interaction. So yeah, it's cool that we find that people that drink more alcohol are more aggressive than people that don't drink alcohol, but I want to see whether this is true for my boyfriend, who might be on the lighter side, versus his dad, who might be on the heavier side. So if it affects his dad more, then I might try to limit his dad's alcohol intake at our baby shower because I don't want drama to go down, versus my boyfriend, right? So we care more about the interaction than we do just about drunkenness, the main effect of drunkenness. All right, so now let's go over all of the different main effects and interactions that you can have in a two-way or a 2x2 factorial design. So this is something that, Haley, you might want to think about, because these are all the main effects and interactions that you can have. There are many. Okay, here it's telling you that there's no main effect for cell phone, there's no main effect for age, but there is an interaction between age and cell phone use. And you can tell the main effects because of the averages that we took, like we talked about earlier. You can tell there's an interaction based on the graph. All right, so let's see. Is there a main effect for cell phone? No, 7-7. Is there a main effect for age? Yes, 10 versus 4. Is there, Alicia, is there an interaction between cell phone and age?
No.
No, why?
They the lines in the graph seem to be pretty parallel. They don't.
Perfect. You got all the points. Yes. So you would get half credit if you're like, no, but you need to tell me why. Okay. Main effect for cell phone. Yes, there's a main effect for cell phone. 10 versus 4. There is no main effect for age because 7 to 7 is exactly the same. Alicia, is there an interaction?
I just see the one line, so I don't
They're both on top of each other. How could they cross? They're like
Oh.
literally the same on top of one another. So no, there is no interaction. Like you can't even see the other line. It's just like one super thick line. There is a main effect for cell phone. So cell phones cause more accidents than not cell phones. Here we can see 10 versus 7. There is a main effect for age. Younger drivers have more accidents than older drivers. Then is there an interaction, Alicia?
Yes,
Why?
because the lines intersect, right?
And this is also known as a graph that is only when. So it looks like accidents only occur when you are a younger driver than when you're an older driver. Or accidents are more likely to occur when you're not on your, yeah, it's the younger driver overall, but when you're a younger driver and not on your cell phone, you're more likely to have accidents than when you're older and not on your phone. So these findings don't necessarily make sense. They're just meant to sort of graph the different main effects and interactions. What about this one? Woo, there are 4 more. Is there a main effect for cell phone? Yes, cell phones cause more accidents than not being on a cell phone. Is there a main effect for age? Yes, older drivers have more accidents. And do these look sort of parallel, Alicia? I completely just changed your name, Alicia.
I would say no.
It's not parallel?
No.
Okay, perfect. So is there an interaction?
Yes.
Yes, there is an interaction. Woo. So this is just a trash study. You don't have any main effects or an interaction. So you're not going to publish. Here, do we have main effects and an interaction? We have one main effect of cell phone, 6.5 by 3 versus 3.5. We have no main effect of age, and we have an interaction because it's a perfect crossover. Do we have a main effect of age, 6.5 versus 3.5? Yes. Do we have a main effect of cell phone, 5 versus 5? No. Do we have an interaction? Yes, the points cross. Okay, so those are all the differences that you can have when you have or main effects and okay. This is the combination of all of the different main effects and interactions that you could potentially find in a 2x2 factorial, which is something that Haley's doing. So for Haley, it might be like younger, older, and then one of the lines is women versus men. So Haley, you might play around with using job satisfaction here and seeing what interaction would make the most sense.
Okay.
Or main effects. All right, how's everyone doing? Are you interacted? Like my brain is just, it's a lot. Interactions are pretty tough, but they are very, very interesting. And I think they're like the lifeblood of our field, because we don't just want to see like, oh, is there a difference in prejudice between like white people and people of color, but we want to know when that prejudice might be more exacerbated relative to others. So sometimes when we're looking at interactions, we're looking at things that could happen in the real world to make our studies more generalizable. So, all right, so yeah.
So what, and as far as the last thing you said, then another variable or something, like what would cause it?
Increase in prejudice.
Yeah, I
Um,
mean, you're looking for, so when, I'm just saying, uh,
Are you asking what I think would increase prejudice between whites and minorities?
no, not
Oh.
what would, but if that was one of the questions, was what would be the cause? That would be another level.
Oh yeah, yeah. So if I were to ask you right now, like, okay, what do you think would cause, explain, or exacerbate the finding that white people have more prejudice towards minorities than minorities have towards minorities? What would be one factor that you might want to investigate?
Yeah, I was just sorry. I didn't
But
mean to
no, that's
stop.
my question now. So
Oh.
I might use that on the final.
Oh, for a reaction to something that happens that is seen on the street or something you see.
So that's a dependent variable.
Okay.
So what would be something else that you could measure or manipulate to increase prejudice?
Hmm.
Anybody, Alacia or Haley?
Good question. I don't know.
Exposure to media.
Yeah.
Social
So one thing
media?
could, yeah, so exposure to media, you might present them with like a lot of pictures of notable Black, Latino, Asian, Native American people that might decrease prejudice, or you might expose them to a lot of negative stereotypes, which would increase prejudice. That could be one factor that you could add. Another thing might be perceived, scarcity of jobs, right? Like that's the joke, the meme, like you're taking our jobs. So maybe if people feel like jobs are more scarce, they're going to exhibit more prejudice. So those could be other factors that you could want to investigate to see if they increase, decrease, or explain the generalizability of why whites might have more prejudice. Yeah, that's a good question. Yeah, good examples. So let's talk about factorial variations. We've talked about 2x2s, but there can be between subjects designs, which I sort of hinted at. There can be within groups designs. There can also be mixed designs, which are a headache. We're doing a design with that right now. I'll explain what that means. Increasing the number of an independent variable. So of course, it could be a 2x2, but that's one of the most basic interactions. There could be a 2x2x2. There could be a 2x4x6. There could be all sorts of combinations, but it gets real crazy really fast. And then increasing the number of independent variables. Okay. Oof. So for an independent groups design, it's the same as like within subjects. So both IVs are studied as independent groups. Independent groups is between subjects. So both IVs are studied as independent groups. So you're only given either a very little amount of vodka or a lot of vodka. So a 2x2 independent groups design has 4 cells. So we've already talked about that, also known as a between subjects design. So this is what it would look like. So let's say that you had 12 people per condition. This is the alcohol photo or plant photo, and then the neutral words or aggression words. So if you had 12 people per condition, that means that you would need 48 participants, right? So you would have 12 people who are exposed to the alcohol photo and respond to neutral words. Then you recruit another 12 people, they're exposed to the plant photo and neutral words. Then you recruit another 12 people, they're exposed to the plant photo and aggression related words. And then you have another 12 people and they're exposed to the alcohol photo and aggression related words. So you would have 48 people. Okay, so, but if you had a within groups design, you would need a fourth of that, those participants. You would only need 12. So you would have 12 people do the alcohol photo and the neutral words, plant photo and the neutral words, same 12 people doing the alcohol photo and aggression related words, and same 12 people doing the plant photo and aggression related words. A mixed design is when one variable is a within subjects design, which means that they get exposed to that independent variable repeatedly, or exposed to all levels of the independent variable, whereas the other independent variable, you only see one of the various levels. So here, what we have is people are only exposed to the alcohol photo. So the alcohol photo is the between subjects design, and the words are the within subjects design. So people are only exposed to the alcohol photo, but they're exposed to both the neutral words and the aggression related words. And then people are only exposed to the plant photo, but they're exposed to both the neutral and aggression related words. So this would lead you to have a sample of 24. So this is just showing you the different designs and how they affect your sample size. It's okay if it doesn't make sense yet. We will go through more examples. So the mixed design is where one IV is manipulated as independent and the other is manipulated as within groups, as I just showed. So this is sort of the in-between the within groups design and the independent design in terms of how many participants you need to recruit. All right, so what happens when you increase? Okay, does anyone have questions about the mixed design versus the within design versus the independent design?
Why would you need a mixed design?
So this would allow you to answer the question, is there a difference in the speed of responding to neutral versus aggression related words for those in the alcohol photo condition? This would allow you to answer the question, is there a difference in speed to which neutral words or aggression related words are responded to in the plant photo condition? This would allow you to answer the question, is there a difference between all 4 levels among these 12 people? So is there a difference in alcohol photo and neutral words? Is there a difference in plant photo and neutral words? Is there a difference in alcohol photo and aggression related words? And is there a difference in plant photo and aggression related words on the speed or the milliseconds that it takes you to respond to the words? But this would allow you to answer the question among the same 12 people. And this is sort of answering the same question, but you're seeing among different people. And the strength here is that these 12 people, you might have just accidentally recruited from Alcoholics Anonymous. So if you get an effect, you're not removing any individual differences that could predict the effect. So there is an issue with the third variable problem. In this study, you might recruit, these 12 people might be from Alcoholics Anonymous, and these people might be Mormon, so they don't drink. So any individual differences that might exist, you kind of cancel out. So that's why you want more people. Does that make sense? Does that answer your question, or do you want more?
That answers.
It's okay if it doesn't make sense. Rick, you look confused.
Oh, no, I was just thinking there's probably more problems with the within group.
There's a lot more problems within groups. There are slightly less problems with the plant, like this mixed design. So you get kind of the best of both worlds while saving the number of participants you need. So sometimes researchers are limited in the number of participants they can get. So I know Dr. McCarthy, for instance, he does research with EEGs and fMRIs. And for those kind of studies, you do want the same participants. So sometimes their sample size is like between 5 and 10 people, but you just scan the person's brain like a dozen times or more just to see differences in brain region activation. Because the brain, it's easier to compare someone's brain to themselves versus someone's brain to someone else. There's too much variation. Whereas here we actually want the variation. And this is mostly what we do in like social psych and some economy studies, because we actually want the variation, and we want the variation to sort of cancel each other out. But if you're a poor researcher like I am, I don't have as much grant money, I might say, well, I shouldn't do 12 because 12 isn't part of like my field and my field standards. And I can't do 48 because I don't have any money. So why don't we do 24? So 24 might be a good happy medium. Any questions there? No? All right, so this is when stuff gets a lot more intricate, or research gets a little bit more intricate. So let's say you wanted to increase one of the levels of the independent variable. So we're doing the cell phone study with younger and older drivers again, with braking onset time. But now we have an added level of the independent variable where no phone is used. So are people just really bad at their braking onset time, or is it really affected by just the presence of a cell phone? So this has now become a 2x3 condition, or 2x3 factorial. 2, because the first independent variable has 2 levels, younger versus older drivers. And 3, because we have 3 levels of the cell phone condition, hands-free, handheld, and no phone. So factorials are notated like this. It's a blank by blank, and the blanks represent the levels of your independent variable. So Haley, what would yours be?
For the independent variables?
Or like, what would the blank by blank be?
Oh, well, I only have 2 age groups. It's 20 to 45 and then 45 plus.
Mm-hmm.
And then man or woman.
Mm-hmm. So what would the numbers be? Blank by blank.
Oh, it would just be a 2x2.
Perfect. Yeah, because she has 2 independent
Sorry.
variables with 2 levels of each. Okay. And then here we make a, what numbers would these be? Alacia, a blank by blank.
4x3.
Perfect. Yeah. And it gives us more rich data, right? So we have, with no phone, people's braking onset is a lot faster than when they have a handheld or a hands-free cell phone. So it gives us a good baseline. And this is a different age group. So you could do something like this for your study, Haley, but I don't think it would give you richer data. But here, let's say we wanted to look at different age groups, 20 by 29, 30 to 49, 50 to 69, and 70 plus. And it would give us richer data to see whether there's an interaction between age and cell phone condition on braking onset. But as you can see, you require a lot more data points. So let's say that you required 50 per cell. So now you have 1, 2, 3, 4, you have 12 times 50, you need 600 people in this study now. So that's why we go with 2x2s now, because that's where we start off. It's quick, you only need 200 people. And then if you are interested, you can increase the levels of cells, but sometimes it doesn't give us useful information. This might be useful information because no phone, you want to see how people react on average when they don't have a phone around. This might not give us as much rich data because there might not be a significant difference between the age groups. We might just want younger versus older. All right, so what about the main effects and interactions that you can get from a 3-way design? So that would be when you have a 2 by 2 by 2 design. So the first independent variable would be light versus heavy traffic. The second independent variable would be the cell phone, either no cell phone or hands-free cell phone. And the third independent variable would be younger versus older drivers. So this is a 2 by 2 by 2. Oof, that's a lot. So in order to graph the 3-way design, you would do the same thing by having 2 graphs side by side, one in light traffic and one in heavy traffic. And why would you worry about all of these interactions? So this might give us some useful information, right? So does it make a difference in the age and whether a cell phone is present or not? In light versus heavy traffic, there might be more of an effect with heavy traffic. There might be more of an effect with light traffic. It actually can give us some interesting data. Okay, so let's see. So main effects, what you would do in a 2 by 2, you would have 6 main effects. Or sorry, 3 main effects. So you would have a main effect for cell phone type, So is there a difference in cell phone? In the reaction time to the presence or absence of a cell phone? There would be a main effect for driver age. Is there a main effect for younger versus older drivers? And is there a main effect for traffic conditions? So is there a difference between light and heavy traffic? So in a 2x2x2 study, you would look at 3 main effects. Right. What about two-way interactions? So you have two-way interactions, and now you're going to have three-way interactions in a 2x2x2 study. So is there a difference in differences? You're going to have 1, 2, 3 different two-way interactions that you can run. So you can do a two-way interaction between light and heavy traffic and the age of the drivers, presence or absence of a cell phone and age of the drivers, and then light or heavy traffic and presence or absence of the cell phone. So these would be the two-way interactions that you would run if you had a 2x2x2, so a three-way design. And then three-way interactions. Yeah, it's a lot. So that's where you say, are the two-way interactions different? So is this graph different than this graph? Or sorry, give me a sec. Are these two graphs different from one another? So these are two-way interactions. So it's saying, is there a difference between light traffic, presence in cell phone or not, and heavy traffic, presence or absence of cell phone? And this says that no, there is no significant two-way difference in the two-way interactions because both lines or both graphs look very similar, right? What about these? Do these look similar?
No.
No. See,
Oh, no.
these two graphs?
I mean, no, they just both would cross. That's
So
what
they
I-
both have two-way interactions, but the kind of two-way interactions they have are different.
Okay.
So this would say that there is a significant three-way interaction because there's a difference between the two-way interactions. That's a lot. Does that make sense? Yes, no? So remember,
Yes.
when we have a 2x2, we're just looking at, let me click back. How do I click back? Previous. Okay. So we have main effects. So this is similar to a two-way ANOVA or 2x2, except we're adding on another main effect. So instead of having two main effects, now we have three main effects. And again, two-way interactions, we add some interactions. So these are the same as the two-way or 2x2 ANOVA or a 2x2 design. We have two-way interactions, but now with the three-way interactions, we're comparing the differences between the two-way interactions. Does that make sense?
Yes.
Okay. You will not have a two-way interaction in this class, or sorry, a three-way interaction in this class, hopefully. But it is a lot. So here, is there a difference in the interactions between light traffic and heavy traffic?
Not so much.
They look very similar, right? So the patterns look very similar. So no, but here, the gap here tends to be smaller than the gap here. The pattern seems to be a little bit different. So the one on the left side is the opposite of the one on the right side, heavy traffic. So there is, yeah, so like here, the biggest gap is with the no cell phone, and here the biggest gap is with the cell phone. So there is a three-way interaction because the pattern seems to be flipped. The great news is, one, I will likely not ask you any questions about three-way interactions. Two, if you ever run a three-way interaction, you won't just have the graph to rely on. You're going to have data and you're going to have a p-value and you're going to be able to see whether there's a significant difference in the two-way interactions. And then what you do when you have a significant three-way interaction is that you have to compare. So like I had to learn how to compute syntax, which is like coding language for each of the different comparisons to see where the difference in the two-way interaction lies. So you have to do even more statistics. So yeah, there's a significant difference in the two-way interactions, but then you have to do follow-up to see, okay, where are those differences? So it's a lot. All right, we're almost there. Why worry about all the interactions? Most outcomes in psychological studies are not main effect, but rather interactions. If it were just main effects, that would mean life was really simple and one-dimensional, but the interactions allow us to generalize, to find when things happen, what the limits are, and so on. All right, so how do you identify factorial designs in the articles that you read and in popular press articles? You look at the method section in an article. If it says it was a 2x2x3 or a 4x2x1, 2, then that's a factorial design. The results section will also examine main effects and interactions. So you'll refer to significance or p-value and information about a MANOVA or a 2x2 ANOVA. So you'll talk about main effects and interactions. When you just have one independent variable with two levels, you don't study interactions. You just study effects. So another way to determine whether you're looking at an interaction in a paper that you're reading is look for this kind of language. They say it depends, or it only happens when. And you can also look for participant variables. So are you measuring differences by age, gender, ethnicity, and so on and so forth? That would give you a clue that you're looking at a factorial design. And that is the end of this lecture. That is a lot. I will come up with questions based on this lecture for next lecture, but next lecture should be short. We'll only talk about discussion, and we'll talk about the IRB. And then, let me see, I'm looking at schedule. And we're in week 7. So we'll only have class next week, and then the following 2-3 weeks you'll have for writing your paper, which is great. You will also have those 3 weeks to schedule time with me. You can schedule time with me during class meeting times because now I'm free during those times. You can schedule time with me during office hours. And also, if I ever reply to an email, you will note that there is a schedule a meeting with me link there. Those are my advising hours because I'm an advisor. Students aren't signing up for advising. So if there's an open meeting there, you can sign up to meet with me there. So I'm available. Let me just look at my calendar so you can see. Just ignore my email. I don't know. I have so many unread emails. Okay, calendar. So these are the times, so I'm not available then, but I'm available from 2 to 5 on Mondays, 9 to 12 on Tuesdays, 9 to 10, and 1 to 5. So I'm available a lot of times, plus in addition, all the times that we would normally meet for Zoom meetings, plus whatever hours I have for office hours. Maybe schedule an appointment there. So I have a lot of availability if you want to meet during those times to talk about your paper. So please meet with me. I'm more than happy to help. Cool. Any questions? Can you leave now? Yes. Let me